practice problems. If you want more to do, we were working on some of those before school, so you can jot those down and try them. We will do some more of those really hard ones that come at the end of that in just a few minutes. So as I come around and check homework, do we have any volunteers that want to do, maybe come to the board and do all three of those? Always nice when volunteers volunteer voluntarily. Let's see, how about Isabel, you want to pick one of the whiteboards, and it's Emily? Emma, I was close. You want to pick a whiteboard, and Parker, you want to pick a whiteboard there, and Jeremy, you want to pick a chalkboard up here on that side, and I'm going to come around and let me see what I need in terms of homework here. So I think I'm getting 9, 10, 11, 12, 13, 14. I'm a little on the behind side. So let's see what we've got. The last one I have seen is number 4. So we can be on that. So think about, do you want to try to take that quick test back from you? Okay. Talking is encouraged here, so you can consult.
I think that for the log, it has to be greater than 0. Like the inside. So like x minus 6 has to be greater than 0. And then solve that.
We have no two. Okay, good.
Yesterday's notes I forgot to.
Good, that was good, huh?
Thank you.
7, 9.
What's your
So.
So we get for the domain
I got it.
I know.
Couldn't it just be?
It's gonna take a little bit of getting
Yeah.
used to, but we'll get there. Oh, yeah, yeah, yeah.
So x plus 5 has to be not equal to 0. So x cannot equal 0. So then it's all round numbers. X cannot equal 0.
The second one, go.
For e of x, I got x is greater than 6.
How we doing? Think okay? Getting positive feedback from your teammates here? So the issue, so each of these has different issues. So the first one, the issue is you can't get 0 in the denominator. Positive or negative is not the issue. So the only thing we can't have is that x plus 5 can't be 0. So that means that x can't be negative 5. Okay? The next one, a logarithm. What's in the logarithm cannot be negative, nor can it be 0, which means whatever is in the logarithm must be strictly greater than 0. And then when you solve that, that's going to be its domain. And we can, if you want to be proper, we could do that. That's not a big deal. Now here the issue is you can't be negative. 0 is okay because we can take the square root of 0. So we have 2 minus x has to be greater than or equal to 0. So that means that when you multiply or divide by a negative, you have to switch the direction of the equality, and that's going to become your domain. Good to go? All right. Very good. Thank you. You can go ahead and destroy the evidence up there, and we're going to do now move to the hard ones. The ones that have squares in there in the radical, or ones that have big fractions. So we'll say f of x, and we'll do these one at a time. So let's say we've got x squared minus 49. Do you need a strategy to talk strategy before we send different people up here, or are you feeling bold and confident? So strategy, somebody help us out. So how are we going to start this thing?
Group what's inside of the radical and make it greater than or equal to 0.
Exactly. So like the earlier radical one, whatever's inside here has got to be greater than or equal to 0. Now, the next two things are important. What's the next step we're going to do? Factor it. Exactly. Not just add the 49 to the other side of the greater than or equal to sign. Once you factored it, then the next big step is what are we going to do? You have to do the number line and analyze the sign on the number line. Okay, 4 more volunteers that haven't volunteered already today. Nora's got one. 1, 2, 3. 1, 2, 3. Take the whiteboard there. Oh, you got to volunteer quick, Grace. All right, Jim. Yes. Oh. Hold on, Nora, I'm gonna play you a random sequence there. You ready? How good are you at catching?
Oh.
Oh,
Not
you
fantastic,
got
but
skills.
no.
Nora, a little stability. That sound like you, Jeremy? 18 for half credit. Come on. Did you get a review from last time? Did you write your answers in? So where is the donor? We need to see that as something.
Number one.
Okay, so our strategy is to take what's inside the radical, make it greater than or equal to 0. It is not good math to add the 49 and square root both sides, because with an inequality, we don't have good meaning from that. So instead, we are going to factor that as the difference of two squares. Then we're going to go to the number line, and we're going to put in where this is equal to 0. That will make these solutions. We'll test each of those regions. So if you put in, say, a -8, -8 minus 7 is a negative, -8 plus 7 is a negative times a negative is positive. That's greater than or equal to 0, so that is going to be part of our domain. Putting in 0, we get a negative times a positive, which is negative. That's not greater than or equal to 0, so we don't have anything in the domain from there. Plugging in 8s, they both become positive. That's going to be part of the domain. So we write that as two separate inequalities with the word or in between them. Okay? Similarly, but different, I'm going to give you g of x is the square root of, and we will say x squared minus 81 minus x squared. Okay, back to the first group that was up here. You can return to the scene of the crime and do that one.
What?
The top will also stay white.
I like writing with the chocolate so much.
I think you have to. Yes.
I like the sound.
I don't. The sound is what bothers me. It doesn't bother me at all. Like, I don't like how clicky it is. I hate it. Like, whatever you tap it.
Sage is not here, correct?